Hello students, welcome to my channel Anandsir-online.com. I teach mathematics to GMAT, GRE and SAT students. Today we will be discussing one very important topic of SAT, which is sum and roots of a quadratic equation. Sum and product of the roots of a quadratic equation. Let us suppose we have a quadratic equation as ax square plus bx plus c equal to 0. We know that if we use quadratic formula, we can get two roots as x equals to minus b plus root b square minus 4ac upon 2a, and second root is minus b minus under root of b square minus 4ac upon 2a. Let us suppose that the first root is alpha and the second root is beta, right? Now, if I add the two roots, say alpha plus beta, what I get? I have to add this and this, right? So, the LCM becomes 2a. The numerator we have minus b plus root of b square minus 4ac, and when we add this we get minus b minus root of b square minus 4ac. So, what I see that this and this cancels out. We are left with minus 2b upon 2a, that is minus b upon a. So, sum of the roots is minus b by a. Also, if we need to find the product of the roots, say alpha times beta, it is minus b plus root of b square minus 4ac upon 2a times minus b minus root of b square minus 4ac upon 2a. So, when I multiply them, I can use the formula of x plus y times x minus y and we know that that is equal to x square minus y square. So, it becomes minus b whole square and minus root of b square minus 4ac whole square over 2a times 2a, which is 4a square. Simplifying the numerator, we get b square minus b square minus 4ac over 4a square. So, when I open it, b square and minus b square cancel out, we are left with 4ac, because this minus minus becomes plus over 4a square, and by simplified further I get c upon a, because 4a and 4a cancels out. Therefore, we can say that the product of the root is c by a. So, what we have learned so far? We have learned that for a quadratic equation ax square plus bx plus c equal to 0, sum of the roots is minus b by a and product of the roots is c by a, right? And if you need to construct a quadratic equation whose sum and product is given or whose roots is given, you use the formula px equals to k times of x square minus sum of the roots into x plus product of the roots, that is k times of x square minus b by a. So, it becomes plus b by ax plus c by a, right? This is a quadratic polynomial and we get ax square plus bx plus c whole upon a, that is k by a times of ax square plus bx plus c. This is the quadratic polynomial which we get when sum and product of the roots is given. If we need to find the equation, what we do? We just simply put this equal to 0 and we get ax square plus bx plus c equal to 0. And what is k in this case? K is a positive, a non-zero real number. Because if it becomes 0, then whole polynomial becomes 0, right? So this is how we find the sum and product of the roots, and if roots are given, we can find the quadratic equation or the quadratic polynomial. Let us move to the questions. There are two questions given. First question is, if one of the root of the quadratic equation is 1, then what is the other root? So quadratic equation given is 2x square plus x minus k. One of the roots, say alpha is equal to 1. We need to find beta, right? And here sum of the roots alpha plus beta is minus b by a, that is minus 1 by 2, because b is 1. And alpha value is 1, we need to find beta. So beta becomes minus 1 by 2, which is minus 3 by 2. So B is the correct choice, right? For question number 2, if the roots of the equation are alpha and beta, what is the value of 1 upon alpha plus 1 upon beta? Here 1 upon alpha plus 1 upon beta can be simplified by taking the LCM. And in the numerator we get alpha plus beta or beta plus alpha. What is beta plus alpha in this case? It is minus b upon a, that is minus 4 upon 1, and alpha beta is c upon a, that is minus 12 upon 1. So it becomes 4 upon 12, which is simply 1 upon 3. So right option is B. So dear students, hope you have understood this concept. If you have any problem, just write down in the comment section. I will definitely get back to you. You can also WhatsApp me on the number given below. Thank you so much for watching. Do like it, share it and subscribe it. Bye-bye.